Hello everyone. In this video, we will learn how to apply machine learning models on a dataset called as the Black Friday sales dataset. So before getting any further, let us know what this dataset is all about. So over here, Black Friday is an informal name for the Friday following Thanksgiving Day in the United States, which is celebrated on the fourth Thursday of November. Many stores over here offer highly promoted sales on Black Friday and open very early, sometimes as early as midnight. So this is a sales dataset, and before we work on this dataset, we'll have to import some libraries, which are the pandas, numpy, seaborn, and matplotlib. So what really pandas does is that pandas will help us to create data structures and manipulate these data structures. So even in order to read our data set, we'll have to use pandas to read our data set, or else we won't start working on our data set without pandas. So pandas will basically help us to work on the data structures. Okay. And then we have numpy, and numpy will basically help us work with arrays. And at the same time, numpy stands for numerical Python. And apart from working with arrays, NumPy also has domain or algebra and matrices. And then the third input, as you can see over here, is the Seaborn. So Seaborn is a data visualization library, and it is based on Matplotlib. And the other thing that Seaborn can be used is to visualize statistical graphs. All right. And then we have Matplotlib. Matplotlib is something that is used to create plots, and it is basically a plotting library. And then our next import over here is the label encoder. So label encoder, what it really does, let's say we have a column which has colors in it, like the red, green, blue. So what really a label encoder will do is that it will convert these categorical variables into numeric. So the colors, let's say we have three colors, red, green, and blue, it will convert it to 0, 1, 2, something like that. And then we have standard scalar over here. So what standard scalar will do is that it will transform data in such a way that its mean is 0 and the standard deviation is 1. And then we have imported train test split. So it is with this train test split, we will change our data into train and test. We'll basically divide our data into training and testing parts using the train test split. And then I've used three machine learning models over here. One is the linear regression, the other is the decision tree regressor, and apart from these two, I've used the random forest regressor. And in order to compare which model works better, we'll have to evaluate them. And in order to evaluate this model, we'll have to import metrics. And the metrics that we have used to evaluate this model are as follows: mean absolute error, mean squared error, and R2 score. So basically, these three will help us to evaluate how well our models are performing. The next thing that I've done over here is that I've loaded the dataset. So as I told you previously that we use pandas, and we have used pd.read underscore csv, and this is the way how we read our data, and the data is a csv file, and it is called as train.csv. And after we have done the reading part, we have viewed our dataset, and we have displayed it by running the df cell over here. And this is how our dataset looks like. All right, it has a few columns over here, and this purchase column over here is our target column. And in order to see how this data really looks like, we have to do, and I've done data understanding, and I've used the df.shape in the beginning to display the total number of rows and columns present in our data. So as you can see, the df.shape will show the total number of rows and columns present in our data set. So basically we have 5,50,068 rows and 12 columns in our current data set. So the next thing that we have done over here is we have used the df.describe function. So the describe function, what it really tells us is that it shows us the descriptive statistics of our data, and the shape of the data distribution. So it gives an overview of how our data looks like. So as you can see over here, this is a user ID column. So we'll avoid this column for now. So let's go with the occupation column over here. And in the occupation column, the minimum values are as 0 and the maximum values present in the occupation column is 20. And similarly, we can see how our descriptive statistics of this data looks like in the other columns as well. The next thing that we have done is I have used the df.info function over here, and the df.info function shows us two things over here. One is it can help us to detect if there are any null values present in our data set. The other thing it shows us is the types of data present in the columns. So let's say this is the user ID column over here, okay? And we have 5,50,068 rows here. So we can see that there is a similar number over here. That means there are no null values present here in this column. And the types of the type of this user ID is integer type. And similarly, same thing can be seen over here in the product ID. We have the same amount of rows here, but the type of data is object type. And similarly, you can see the remaining columns as well. But over here, there is a column called as product category 2. And as you can see over here, the number of rows over here are not matching with the number of rows present here. Okay, we have 5,50,068 rows, and out of them, there are around 3,76,430 null values in this data in this column. And over here, you can see that product category 3 over here. There are again some null values present in these columns. There is a mismatch over here, and the type of this column is float. And similarly, you can see that the purchase has no null values in it, and the uh, type of the column over here is integer type. So in order to get a total number of how many null values are present in this column, we can use another code, that is df.isNull.sum. So it will give a clear picture about how many null values are present in our data. So 0 means there are no null values present in this particular user ID column. But over here you can see that the product category 2 has some missing values over here, which is 1,73,638 missing values. And the product category 3 over here has 3,83,247 missing values over here. You can see the same thing over here as well. The product category 2 and 3 have a mismatch compared to this original rows present in our data. And this has to be further handled, and we'll do it later. So for now, we have done the data visualization part. And as you can see, I have used a count plot in order to compare the percentage of occurrence in the gender column. So over here, the count of a male is higher compared to the female. The second visualization over here shows us the gender and marital status. So this visualization shows us that the females are higher compared to the males when it comes to marital status. And let us go for the third visualization over here. The third visualization over here shows us that the male gender is higher when it comes to purchase made by a specific gender. And over here we have male on the top followed by the female. And this is the third visualization. And in this visualization we can see the types of occupations a particular person has, and the purchase amount, the purchase is done by a particular occupation. So in this graph, three occupations 12, 15 and 17, 12, 15 and 17 have a higher purchase compared to other columns or other occupations. The other visualization over here shows us the gender by the in the gender column we have two keys over here. One is the female and other is the male. Female is represented by the blue and the male is represented by the orange color over here. So one thing this visualization shows us is that the female gender in the occupation 18 has the higher purchases compared to other gender as well as other occupations. The next thing that we have done over here is an outlier detection. So let us see what an outlier really is. So an outlier is nothing but an observation that lies at an abnormal distance from other values. So an outlier nothing but data points that are very far or further from other data points. And these outliers have to be treated, or they create problems for many statistical analysis because they can cause tests to either miss significant findings or distort the real results. And the next thing that we have to do in order to detect an outlier, there is a technique which is called as the box plot. So we basically visualize our data in a form of box plot in order to find an outlier or detect any outlier. And this outlier can be treated using the interquartile range as well. For now, we'll use only box plot to visualize our outliers and check the presence of outliers in our data. So over here, I've taken gender on the x-axis and purchase on the y. And as you can see over here, there are points above 20,000. These are nothing but outliers. So at the same time, we have done more visualization and used more box plots. And over here, we have taken occupation on the x-axis and purchase on the y. Again, as you can see over here, we have outliers in this as well. And the outliers are about 20,000. So any point about 20,000 here is an outlier. And over here, this is another box plot. And I've taken age on the x-axis and purchase on the y. And again, as you can see, the points about 20,000 are outliers. And this is the outlier, this is the box plot. To detect outliers, I've taken a product category on the x-axis and purchase on the y. And as you can see over here, these points are the outliers. These can be treated, but for now, let us see how the performance of the model goes without removing these outliers. So the next thing that we have done over here is we have moved ahead with the data pre-processing part. So the data pre-processing is nothing but it is a data mining technique which is used to transform raw data into useful and efficient format. So this is our data over here. This is the initial data. This is how it looks like. And let us go ahead and pre-process this data. So what I've done over here is that we have product ID column over here. And in this product ID column, we see that there is a pattern that repeats in the entire column, and that is P00. The first three characters over here in the product ID can be removed and standardized. So I have used the replace function over here, and I have replaced the P00 part and I've removed them. And then I've standard scale this product ID column. And in the end, I have used values.reshape. So what this really does is that the reshape will it'll give a new shape to the array. And the next thing over here that can be seen is I've dropped a column which is product category 3. And the reason why I've dropped this column is because when you check the isnl.sum, you see that the product category 3 has around 3,83,247, and that is a lot of missing value in our data set. And when you have missing values, that is like more than 50% of the data is missing values, then you directly drop the column because it cannot be imputed. And even if we impute it, the accuracy will change. And let us go ahead, and I've dropped this column over here. I've dropped the product category 3 as more than 50% of the data was missing. But when it comes to product category 2, there was not a situation where more than 50% of the data was missing. So what I've done is I've imputed this column with the help of mean, and this code over here uh, is using the fill NA function over here, and I fill this null values in this particular column with the mean. And as you can see, after the imputation has been done, there are no null values present in our dataset anymore. I'll use the df.isNull.sum again, and as you can see, we have zeros everywhere. That means we have successfully imputed our null values, and now this is how our final dataset looks like. The next thing that we do over here is that we have to label and code a few columns. Like we have a few columns like the gender and city category. So these columns are having objective, I mean, they have, ob these columns have categorical variables in them. So we have to encode them and convert them into integer. So I've used the gender, city, category, and age columns over here, and I've label encoded them. And for I in category columns, so basically this code will take all these three columns and transform them and label encode them. And so after the encoding has been done, you can check the types of these columns now. So we have taken gender, city, category, and age. So as you can see, the city category, the age, and the gender columns have been converted to integer types. The next pre-processing part that I've done is there is a particular column that is called as the stain current years, stain current city over here. As you can see, this column has values. This has integers, but at certain places we have a 4-digit which has a plus symbol to it. So we have to remove such symbols, and I have used the replace function, and I have removed the using this replace function I have removed the 4 plus and replaced it with the only number that is 4. And the next thing is that I've converted these integer 32 values to integer types. So I've taken the gender column, age, and stain current city years, and I've converted them into int using the astype function. The other thing that we can see over here is that the city category is basically integer type. So city category, as you can see, it is int 32. I've converted into category again using the astype function, and this is the final pre-processed data set that we have remaining in our uh, right now. This is our final remaining data set, and the next thing we have done is I've used a distribution plot on this data set. So what really distribution plot does is that it shows how the overall data is distributed in our data frame. So as you can see over here, in probability theory and statistics, skewness is a measure of the asymmetry of the probability distribution of a real valued random variable about its mean. So basically, a distribution plot will help us to find out if our data is skewed or not. So I've plotted our distribution plot over here. And one thing to be kept in mind is that distribution plot will only take integer type values over here, and it won't work for categorical uh, columns. So I've used 3 rows and 3 columns over here, and this is the figure size, which is 10,4. And so as you can see, this is the distribution plot. And what I've done is, if we have our data which is skewed in nature, then we can apply log transformation on those particular columns. So I've used log transformation on a purchase column over here. And a log transformation, what it really does is that it will transform the data which is skewed and change them into normal distribution. So after applying a log transformation over here using np.log, we have like successfully done the log transformation on our purchase column. The next thing that we have done over here is we have used the pd.getDummies option over here, and using that we have additional 3 columns, which is the city category 0, city category 1, and city category 2, which were not there in the previous data set. We have successfully created dummies as well, and we can now move ahead with the train test split part of our machine learning. So now, before splitting our data into train and test parts, what we really do is we separate the dependent and independent columns from our data set. So over here, we have removed the purchase column using the drop function, and on Y we have given the purchase column. So as you can see, this is how the x dot head looks like. We have all the columns in them except for the purchase column, and on the Y we have all the purchases. We have the purchase column on the Y, and these are all the purchases. And once we have divided our data into x and y, once we have separated our independent and dependent variables, we can go ahead and split our data into train and test. And over here you can see that 80% of the data has been used for training purpose, and around 20% of the data is used for testing. And over here you can see that I have taken the x and y, which are the independent and dependent columns, and the y was the target column over here. And as you can see, the test size over here is 0.2. So what this really means is that if we give the test size as 0.2, then 20% of the data will go for testing purpose, and the remaining 80% of the data will be used for training purpose. So if you change the value from 0 to 0.3, then you will have 30% data for the test and 70% data for the training purpose. And over here, the random state has been given as 0. So what this really means is that, let's say two people out of five use the same random state, then they both are likely to get the same results compared to others. And these are the X train shape and the X test shape, Y train and Y test shape over here. These are the shapes of our X train and X test. The next thing that we have done over here is we have applied standard scalar. So what standard scalar really does is that it will standardize a feature by subtracting the mean and then scaling it to unit variance. So standard scalar will scale our data. And next thing that we have done is we have applied machine learning over here. So as I said previously, we have only used three models over here. One is the linear regression model, the other is the decision tree regressor, and finally we use the random forest regressor. So here, as you can see, we have used the linear regression model, and we are fitting the model, and we are fitting on X train, Y train. And then what we have done over here is in this piece of code, we are predicting it on the X test using model.predict. And then finally, these are our evaluation metrics that we talked about in the importing section. And we've used here R2 score, mean absolute error, and mean squared error. So how do you exactly tell if your model is working well or not? It is decided by the R2 score. The R2 score should be close to 100. The closer to 100, the better the model. And the remaining mean squared error should be as less as it can, as less as it is possible. So over here you can see that the root mean squared error is 0.66. So our objective would be to reduce this values over here, which is the RMSE. We must make sure that this RMSE value is low and the R squared value is high. And the above evaluation metrics help us to find how well our model is performing, as I told you earlier. And as we can see, the R2 score is only 0.20, and as the RMSE is high, the model is not performing well, and we'll have to move on to the other models as well. So let us go ahead and apply a decision tree regressor. I've already applied the decision tree regressor over here, and same thing has been done over here. I have given a max depth that is 9, and I've fitted the model on X train and Y train, and I've predicted it on X train and X test. And finally we have our evaluation metrics over here, and as you can see over here, the RMSE value is comparatively less as compared to the linear regression model over here. and over here the RMSE was 0.66, and now in the decision tree regressor our RMSE has reduced to 0.36, and which is a change. This means that the decision tree regressor model over here is performing very well compared to the linear regression model. And let us go ahead and see the R squared value over here. And as you can see, the R squared value is 75, which is pretty good as compared to the linear regression model, which gave us the R2 score as 0.20. So we can clearly see that the decision tree regressor is performing very well as compared to the linear regression model. So after this, let us read this. The decision tree regressor is better compared to linear regression, as it can be observed that the RMSE is less as compared to the previous model, and the R square value is higher in this model. So the next thing that we have done over here is I've used the random forest regressor, and using the random forest regressor, we have again fit the model on X train and Y train, and we have predicted the X train and X test. And over here you can see that these are our evaluation metrics over here again, and over here our root mean squared error is less, and our model has a R squared value of 0.77. Let us compare it to the previous model, and as you can see, the previous model gave us an R squared value of 75, and over here we have a 77, which means that this model is performing well. So the decision tree regressor and the random forest regressor have performed very well compared to the linear regression model. And the random forest regressor model is again better than the previous model, as we have a lower RMSE value and the R squared is higher than the previous model. And the next thing that we have done is we have loaded our test data, and the test data is called as test.csv, and we have loaded this data, and this is how the data set looks like. And one thing to be noted over here is all the pre-processing and cleaning part that has been performed on a trained data set has to be done on the test data set as well. And we have done the same thing over here. We have checked if there are any null values using the isNull.sum, and again we can see that these two columns have missing values in them, and over here these null values have to be treated. And at the same thing, these test data set has also been pre-processed like the trained data set. So same thing has been done on the product ID column. The P00 value has been removed, and this column has been scaled. Same thing has been done on the product category 3. We have dropped the column as more than 50% of the data set was missing in this particular column, and the product category 2 column was previously imputed using mean. Same thing has been done on the test data set as well, and as you can see, we have removed all the null values from the test data set, and using the isNull.sum we can see there are no null values present in the test and the trained data set. And over here this is the data set, and as you can see over here, this column stain current city years has this symbol 4 plus. So let us go ahead and remove that symbol as well, but before that we have to like label encode our columns like gender, city, category and age are categorical in nature. So we have used the label encoder and encoded these three columns in a numeric way, and over here you can see the columns are integer type again, and similarly we have encoded our columns, categorical columns, and converted them to integer types. And next thing over here is that we have removed the 4 plus symbol and replaced it with 4, as we had done on the trained dataset, and then converted these integer 64 values of gender, age and stain current years to integer types. And then we had the city category column, which was integer type, as you can see over here, integer type. And then we have converted it into a category type. And then same thing has been done on the test dataset. We have done the get dummies. We have used the pandas get dummies function. And again, we have a few additional columns, the dummy columns, that is city category 0, city category 1, and city category 2. And let us check the shape of our train and test data. Over here, you can see that the train data has around 5,50,068 rows and 13 columns, and our test data set has 2,33,599 rows and 12 columns. The reason why we have one missing column over here is because the training data had a purchase column in it, whereas in the test data we do not have that purchase column. We are supposed to predict that column based on this trained data sets, machine learning. And over here, this is the trained data set, and over here you can see that we have the purchase column, but when it comes to test data set, we do not have that purchase column, and that's the reason why we saw the shape of our data set to be different. And the next thing that we have done over here is we have used the random forest model and predicted on the test data set now. And we have saved this into a data frame. We have used the columns user ID and product ID from the test CSV, and we have concatenated our predicted value to this data frame over here. And in the end, you can see that we have our purchase column, and this is the predicted value, and this predicted values along with user ID and product ID have been saved into a data frame called as Black Friday prediction.csv. And that is how we have done our machine learning model on this Black Friday sales dataset. And that's it for this video. Hope you like this video. Have a good day. Take care.